All right. Hello, everyone. I'm Chris Chinnock. I'm the Executive Director of the 8K Association, and we're putting together these 8K sessions at SMPTE. Tonight's topic is on 8K workflow trends. So yes, in cooperation with SMPTE and the 8K Association. So for folks who don't know about the 8K Association, we are an industry organization, not for profit, and our goal is to educate both consumers and professionals. That's what this seminar is all about today. We want to encourage the expansion of 8K in the ecosystem, and we want to embrace all aspects of 8K. So we recognize that 8K is becoming more popular in capture. It's becoming more popular as TVs, but a lot of the stuff in the middle is not happening. So we don't want to be purists and say if you capture an 8K, you have to finish an 8K. That's just not a reality. So if we can get more people to capture an 8K and master an 8K, even if they distribute in lower resolution, that's fine in our vision. So we also have a focus on the consumer side as well. We have a certification program and these two websites just for background. So I think you know how to use a Zoom. Now that I know how to use a chat box and find it, you can enter your questions there. I do have some prepared questions, but clearly if you guys have questions, we want to get those answered as well. So what I'm going to do is the presentations were pre-recorded and they can stream on the main site right now. But I think that creates a little confusion. So what I'd like to do is actually run those presentations now, and then when those have finished running, the speakers are online right now, so they'll be able to answer your questions once we finished playing those back. And if you want to enter your questions, as they speak in the recording, that'd be great too. So here's our panelists and their presenter tonight: Andy Blondin, who's a senior product manager at Epic Games; Michael Cioni, SVP Innovation at Frame.io; Katie Fellion, Head of Business Development and Workflow Strategy at Light Iron; and Thierry Fautier, who's the VP Video Strategy at Harmonic. All these guys are experts and have a great background in this 8K workflow arena. So I think you're going to learn a lot from them.
Hey everybody, this is Andy Blondin. I'm a senior product manager at Epic Games. Today I want to talk to you a little bit about who we are and what is the Unreal Engine, why use a game engine in the filmmaking process, and what are some of the impacts on digital effects and production. How do we achieve high resolution filmmaking through the process of in-camera visual effects? So what does Epic Games do? You probably have heard of us from the video game side and our wildly popular video games like Fortnite. In fact, your kids probably play the game and you're aware. But what you might not know is that we also create the software that makes the video games. And that software is called the Unreal Engine. The Unreal Engine powers Fortnite, which is a massive video game. It has over 350 million players across the world and runs on almost any device out there. It's really built to scale, and we've had large events with over 12 million people in the game playing at the same time. And with Unreal Engine 4, we've had over 12 million downloads. And during that time, we've seen broad adoption across many industries. So architecture, engineering and construction, media entertainment, simulation and training, manufacturer and automotive, all seen adoption in this space. And now we're headed toward the Unreal Engine 5, which we showed off earlier this year. And one of the key highlights was being able to have almost infinite detail. In this video that I'm showing here is running on PlayStation 5 hardware. And traditionally, video games have been known to only be able to display so much content at one time. But with the newest version of the engine, we're able to bring in film level assets that are direct with no optimization, all displaying in real time on PlayStation 5 hardware. And that leads to very high resolution, high detailed that we've never seen before in the likes of video games. As you can see from some of the examples here, the rich amount of detail that you can pack into one frame. And in fact, if I crop in and see the detail on one of these small statues, you can see that there is a ton of detail. In fact, there's millions of polygons involved in this one small section of the frame. This was brought in from a 3D package called ZBrush, which people traditionally will sculpt film assets into. And usually there's a process of converting those into game resolution assets because they can't be displayed in real time. But with Unreal Engine 5, we focused on eliminating those barriers, which are opening up the doors toward more and more film-like assets. And in this shot, you can see that there's actually hundreds of those statues, which now make billions and billions of polygons, all running in real time, being fully illuminated from the scene above with global illumination. And this starts to blur the line between what is a video game and what is visual effects and what is the filmmaking process. And so that's why many people have chosen to use us in the filmmaking process. There's been over 140 film projects since 2016. Many of those have been in the area of pre-production. And so I want to explain a little bit on the pre-digital age. This is how the production process looked like. And you can see in the middle section here, during production, there wasn't as much digital effects happening. And as we move to the CGI phase, you can see the production shortened, but the visual effects and post processes made it much, much longer. And now during the real-time game engine, you can see that post-production has now slid into this area of pre-production and production, which has made it much more efficient for artists to be able to iterate when everything's in real time and you don't have to wait for these long renders. So here's a quick example of a chart that kind of shows some of this cyclical process of being able to have the previs roll into the live action in the filmmaking and the green screen process. And the areas becomes much tighter in terms of the handoffs between departments. It becomes much more of a cyclical nature. And one of the key areas that's been evolving is this area of live action and LED wall productions. And the first of the LED wall production was The Mandalorian. And this has been kind of popularized, so you may know some of the information, but I'd love to run you through some of the details of the project. So The Mandalorian is a episodic television show that took place and was filmed in Los Angeles on a giant LED volume. And this LED volume was 75 feet wide by 21 feet high and included a number of motion capture cameras to be able to track the camera's position. In a sense, it gave us a giant canvas to be able to display this Mandalorian world on. There was 4 4K outputs all chained together to make a seamless display that was 16K resolution. And you can see here, it was designed in such a way that we would get accurate lighting on the actor as though they were actually there in that world and bringing the environment. And if you look off to the left, you can see that that acts like a virtual set extension. As we track the camera's position, it would parallax and move correctly in with the actual shot. And so you can see here through the camera lens, we would be able to see movement dynamically in the background. So for example, as Mandalorian walks along this, there's a physical set that he's on, but then there's an area where the LED wall meets and it physically or virtually extends out into infinity. And so some of the key things was being able to accurately, with Mandalorian, he had this armor that was so reflective, and being able to accurately get the reflections necessary on the armor allowed us to, we did a 360-degree capture of the video game scene and being able to display that on the wall. And then where the camera looked, we would display something that's called off axis, and it would parallax in that correctly so that the movement in the background pieces would look correct. And so here's a couple shots from production. You can see that we're tracking the camera, the lower right frame. You can see the motion capture markers on there. And this allowed us to have a ton of different dynamic environments and be able to use the LED wall as a canvas to be able to change the mood of the sky and the time of day, and to be able to film all day long, for example, in one particular spot. Even doing indoor shots and extensions, basically, of what you would traditionally build as a physical set. So in this shot here, you can see a practical set build that's on the bottom, but then a virtual set build that extends both into the back wall and then into the ceiling. And the final output of that is, you know, a pretty fantastic effect. In some of these shots, you'll see interiors where there's foreground set builds, but then beyond that is the LED screen providing the lighting and the time of day, and the shots turned out really nice. Similarly, here's an example from the hangar where there was a foreground set build with props and pieces, but beyond that, everything else extended into the hangar was all done through the LEDs virtually. Last, I want to leave you with the sizzle reel that Lucasfilm had put out as part of the project. It was amazing, high resolution filmmaking project with all in-camera LED effects that was pretty revolutionary. So I think it said best. I'll let them share it with you here.
Part of what's been fun about collaborating on The Mandalorian with Lucasfilm and Disney is that we have been able to see through a few technical innovations and a few firsts. In partnership with ILM and Epic, we have put together a system where we can have game engine, real-time render, and video wall technology coming together to create a backdrop for the big, beautiful world of Star Wars.
The volume is 21 feet tall, it's 75 feet in diameter, run by 7 machines, pumping the visuals onto the screen that's being created in pre-production.
Everything in the volume is designed to both light the actors and to be a background that we can directly photograph. So you end up with real-time final pixels in camera. It's really a game changer for filmmaking.
Thank you so much for the quick time that we had. I look forward to the panel and the QA section.
Hello, I'm Thierry Fautier, Vice President of Video Strategy at Harmonic, and I'm happy to share with you my perspective on 8K broadcast and streaming. We'll go through the different agenda items: roadmap, 8K live workflow, 8K down to 4K conversion, 8K harmonic production, and then some conclusion. Let's look first at the timeline of what has happened in the 8K space. You see, we all started with the first announcement of 8K TV in 2018 at IFA. Then we had, end of 2018, NHK launching their DTH service. 8K Association was opening up in NAB 2019. Then we had the first demonstration of 8K over 5G for France Télévisions, and Harmonic was participating to this exciting project. Then we saw at IBC 2019 the first SVOD service announced by the Explorer on the Samsung platform. And then we will see, hopefully in 2021, the Tokyo Olympics, and then in 2022, the Beijing Olympic. I've put under those major events what's happening on the codec space. So you see HEVC now available on all 8K TV. We see now AV1 being the new codec being deployed on a new 8K TV set in 2019. And then at the very end, you will see new codecs, next generation codec, VVC, EVC, and AVS in China that will populate new device probably around 2023. Important for you to understand what are the different technical specifications for the 4K and for the 8K, who are all under the Ultra HD umbrella. And this was actually something I've developed with the Ultra HD 4K Twitter account owner. And you see here all the different aspects, the consumer electronic, the MPEG profile, resolution, frame rate, color depth, color gamut, dynamic range, audio. So it's quite complicated and populated, but it gives you a crisp definition of what is 8K and when we should start to consider 8K, which we mainly driven by the resolution. But also we need to have all the goodies, wide color gamut, high frame rate, and NGA audio as we have today on 4K. Important to understand that 8K can be transmitted over two types of media. First, it's obviously the broadcast media where you compress, you multiplex, and you modulate, but you see more and more delivery over IP being mostly OTT, and here you have the compression, different format than the broadcast. Origin server CDN is going to push the content to a OTT network that will be directly processed by the TV set. So I'm going to present here what was done with France Télévisions for the RG Lab in 2019, in May 2019. So the content was captured on the central court Châtrier via a mobile or fixed camera. The content was then carried over optical link of SDI. It was compressed down to 5 gigabits per second and then sent to a video switcher. This is then sent to a live 8K encoder, SDI outputting IP, and you see this IP transport stream single bitrate around 80 megabits per second is sent to a transport stream network. The same IP output is then compressed using a live ABR encoder provided by the VOS Harmonic platform. And this is very interesting, compressed at a much lower bitrate. You see here, we talk about 40 megabits per second. So how this is done? First, you have much more processing capability using cloud technology. But second, you also have this content-aware encoding that adapts the bitrate to the content complexity. So in average, we can roughly bring the bitrate to 40 megabits per second, still preserving the quality. This is then put to an origin server who's going to package the content and is going to output this to the Dash IP network. Very important. This offers live, VOD, and also catch-up capabilities. On the playback side, the transport stream via satellite or terrestrial can be directly playback by the TV. And here we took a Samsung TV for this demonstration. But second, we also are capable over IP to receive a Dash multi-bitrate stream, send directly to the TV. And this is something we have demonstrated at the IBC 2019 with our friends of Samsung. So one of the interesting aspects of 8K is the bandwidth is still high, the complexity of production is still high, and broadcasters are still not convinced they will be able to make money or attract new users using 8K technology. So one way to work around this problem is to take the 8K production, to down convert it, and to use an existing 4K production and distribution infrastructure. And then the 4K receiver is going to let the TV set up convert the content to the TV. And this is what, for instance, Samsung was demonstrating with a technology called ScaleNet, but we believe there will be more progress in that space with or without guided metadata to help the upconversion. As I mentioned, Harmonic is also very interested to understand how to handle 8K format and what to do from a production point of view. So we took a soccer game in Latin America, in River Plate, Argentina, and we were able to demonstrate how the 8K technology can really shine. So you have one view, which is the wide angle. You can see we capture the full game on one single frame. So we have a full field. We can also see the crowd details we never saw even in 4K. We can have a much stronger zooming capability. And you see, last but not the least, the eagle eyes from a drone. We are capable of shooting really with a high quality, high precision from a very wide angle. So to summarize, 8K broadcast already in service. Next frontier is 8K streaming. As you could see, cloud and AI can extend HEVC's life by several years. Next generation codec will not happen before 2023, and the ecosystem is starting to get mature for commercial services. We believe there will be an 8K down convert to 4K interim solution for the years to come. And of course, Harmonic is more than happy to guide you through your 8K journey. We have already published several blogs on the 8K topic, and we would like you to take the time to read them to understand what is behind this 8K technology. So thank you very much for attending my presentation, and I will now pass the mic to my next presenter.
Hi there, my name's Katie Fellion. I am the head of business development and workflow strategy for Lightiron, which is a Panavision subsidiary. And I'm here to talk about 8K post-production roadmap. We're gonna cover a little bit about production and how that leads into post as well. So just to give you a quick background about Lightiron, 8K is one of those things that it sounds like it may be out of reach to some people, but to give some perspective, Lightiron's been doing 4K dailies and DI since we were founded in 2009. We've been posting 6K since 2013, and we've been doing 8K for film and TV since 2016 when the first cameras came on the market. So all that is to say, 8K is not coming, it's here. But similar to how 4K was initially regarded, and in some cases continues to be viewed, it's still far easier to acquire 8K, than to post it. But the benefits can make it worth the effort. So to kick this off, let's talk a little bit about shooting in 8K. There's a lot of studios that are still struggling to understand the justification of why even trying, since we're still trying to get over that hump of 4K in some cases. Well, there's a couple of reasons, and I want to start with one of the creative ones. So this is just a simulation, but I'm gonna talk through some of the advantages of resolution when it comes to 8K versus 4K. So here are some examples of a portion of an 8K Bayer pattern CMOS sensor and a 4K Bayer pattern CMOS sensor. Again, it's just a simulation. Now let's look at lens aberrations. A lens aberration, they're prismatic in nature in that they encompass many colors due to the dispersion of light from the optics. Now, if we place this aberration on the sensor, you'll see that the larger pixel size of the 4K sensor means that we're going to be recording no red color values from this aberration, which you can see has a lot of red values inherent in it. So when we go to display these images, debayering into RGB, the Bayer patterns debayering into RGB, and here's where you're going to see the enormous benefit of shooting in 8K and then super sampling it down to 4K RGB. So see how each of the individual individual RGB pixels is made up of all three colors in Bayer, whereas in 4K we only have one color represented per RGB pixel. These RGB pixels have to do some interpolating now to decide what the other colors should be. So now let's look at the pixels that were hit by our lens aberration. And you'll notice the red pixels that were struck in 8K now produce a red value in the RGB pixels on the left, whereas on the right, since no red pixels were hit by the light, the RGB debayer pixels have no red value now. If we take an average of the colors represented in the pixels on the left and compare them to the average of the pixels on the right, you're going to get these colors. So notice how different those color values are. And let's bring back in then our aberration and place it on top of the pixels representing it. Notice how well the left pixels blend in with the aberration, whereas on the right, the aberration stands out from the pixels. Also notice that the contrast between the colors on the right is stronger than the colors on the left. And this is partially because higher contrast will induce a sharper image, thus making the myth of higher resolution making a sharper image almost false. Higher resolution is going to continue to make smoother transitions between colors as well as more accurate color. So let's get out of the simulation and then see how this applies to an actual image. So in this comparison, we have one of the 8K cameras out there on the market and one that Panavision manufactures, the DXL, that's on the left. And then on the right is a very popular professional lower resolution camera shown at 2K. At 100% scale, those cameras are going to look very familiar, but it's under the hood that is going to influence how much control you really have. So let's take a closer look. With the same lens, you can see that the sensor limitations at 2K versus 4K, and granted, this is a pretty significant scale. Notice how the scaled down 8K is actually creating a softer image with smoother transitions between the details in her face. Also, the colors in her face are far more prominent than the DXL's image. Now look at her eye light, and you'll notice that the lower resolution camera has incorrectly interpolated the light and rendered a blue and yellow hue in her eye light. You'll also notice that the roll-off into the shadow is a little more binary, whereas in the DXL, the roll-off is very smooth and transitional. And again, that's all related back to the super sample of the pixel size as it's captured in 8K and then super sampled down. So to bring this back into a more concrete idea, in addition to the archival benefits of shooting 8K, there's this super sample benefit to increase color separation while reducing noise with oversampled capture. It's another reason to at least consider 8K as an acquisition. Capturing more resolution than you're going to be finishing at can actually help your overall image, not to mention the visible inclusion of creative touches like lens aberrations or more complex skin tones. In addition, when the resolution is doubled, it's going to remove about a stop or 3 dB of noise. So at 2K, you're looking at given noise value. At 4K, we're actually about 1 stop less noise. At 8K, 2 stops less. And at 16K, we're actually at 3 stops less noise. Again, this is the idea of a super sample where we're capturing a larger resolution than what we're going to be finishing at. So all that being said, I suspect before 8K finishing is going to be more widely adopted, we probably need to be capturing more than 8K in order to keep some of these advantages intact. As far as on the cost perspective, since we hear a lot about how much it costs more to shoot 8K, right? I feel like this is something I get to explain every day. But with the advent of efficient codecs and compression options, we can capture 8K rasters that have storage needs on par with 2K or 4K acquisition. As an example, a red 8K 8:1 full frame image is going to round out to about the same data rate storage needs as a 3.2K ProRes XQ. So again, you don't have to pay more to shoot 8K, but in post, well, uncompressed 8K is a little bit of a different story. So we know that shooting in 8K is possible and realistic in many cases. We've been doing it since 2016. But what about posting in 8K? Well, historically, finishing resolutions have always been defined by the display or device. So in theatrical, that's been 2K or 4K historically. Broadcast applications were HD or more recently UHD. And the OTT applications and devices have pushed us into the UHD HDR era. But all that is to say, there are 8K devices out there, 8K displays. There's 8K TVs, there's some limited 8K broadcast networks. YouTube and Frame.io are supporting 8K images. Samsung has their 8K display wall, et cetera. It goes on and on. But we're still going to have some challenges, even though these devices and displays exist, before it becomes more widely adopted in the world of at least scripted content. So let's talk about some of those challenges. Even in this COVID world, what we are currently struggling with, and this is both true in the 4K, but more importantly to the 8K world as well, it is finding monitors that have a high enough quality to represent the creative intent. And look, while we're at it, 4K and HDR have barely touched the set, much less 8K. So that said, 8K displays have only begun to come onto the market for consumers, but we haven't yet made a dent in the professional display world. Before 8K post is really going to be more widely adopted, that's a challenge that we need to face head on. Additionally, in comparison to a 4K 16-bit TIFF, which is a common mastering format for HDR, an 8K 16-bit TIFF is about 4 times the size and storage. This is going to lead to increased costs in the post pipeline, which is where we're going to be working with those uncompressed media formats. That's visual effects, DI, mastering elements. So in other words, the source material, that original acquisition file at 8K is manageable, but once we decode it into a working format, 8K is taking up significantly more resources than 4K, hence an increase in time and cost to process. And then finally, the other big hurdle is the demand for 8K content. We're in a place similar to where we were with 4K in the late 2000s. The displays existed much before there was much content available, much native content. OTT, so over-the-top services, and HDR gave 4K a big jump in terms of adoption into production pipelines, but I'm predicting that we're going to need a similar boost in order to speed up 8K adoption. So let's look at some opportunities. So because we're in this world of social distancing and the theatrical demand is really becoming a more challenging place to be able to review and see content, what we are seeing is a rise in some of potential opportunity in these high-end installs and homes that could deliver an experience that's going to rival theatrical. And that could make a big push in the coming months as theater options continue to decline. But it has to be affordable to the consumer, and we haven't yet reached that threshold. But I'm confident that we'll be able to see some new technologies and some new developments in the market soon. Additionally, on the post-finishing end, the introduction of GPU-accelerated decoding, like Red's partnership with NVIDIA, made reading 8K files significantly easier. But in post, we also have to write them. So we need more working codecs. And I'm not talking about DNX and DNX HD or HR or ProRes, but these are working codecs that make use of efficient compressions for handling these 4 times UHD files. So one of the ways that I think we can really see where this could potentially be captured is certainly in embracing more cloud-based storage and cloud-based workflows. There's a big opportunity that's going to lie in adopting cloud-based options, eliminating the on-premises storage bottlenecks, and potentially leaning into some of the advanced computing power of virtual machines and the like. However, in order to first become more viable, storage companies need to rethink the cost model in order to fit media companies, as that current price per gig is not appealing or scalable within a post-vendor model. Hopefully this gives you an overview of where we are in terms of that 8K post and production pipeline, and hopefully we'll be seeing some more technological developments to make this even easier in the coming months and years. Thank you.
Hey everybody, and welcome to this session for the SMPTE 2020 conference. My name is Michael Cioni. I'm the Global SVP of Innovation at Frame.io, and I'm happy to be here. Thanks to Des and Chris for inviting me to talk a little bit about 8K and some of the future and some vision for that. For those of you that are not familiar with Frame.io, we are an online collaboration process made to power the world's video collaborators. There's a lot of review and approval, there's a lot of sharing, there's a lot of clips all in the cloud. But we also do annotations and sharing for reviews. You can draw on the screen and use that sort of the artistic sense of it, the Ansel Adams way to mark up your work and share that with others. We're also big on integrations with other third-party apps like Premiere and Final Cut Pro 10 and Resolve. And these are all ways that we are connecting the creatives through the cloud into the tools that they use. So this is all exciting stuff. But there's something very special about Frame.io when it comes to this message and story of 8K. Like, this 8K thing, it still sounds kind of new to a lot of people, still seems kind of far off, and maybe for you it seems kind of nutty. And so let's talk a little bit about that and specifically how that works. Now, something very interesting about Frame.io is here's a clip inside of my project in Frame.io. And if I were to zoom into that clip and look at it here, well, you know what's really interesting is Frame.io already supports 8K. So if I click on the 3-dot menu and see the drop down here, we actually get an 8K file. But the 8K file is in there, and you can upload 8K right in Frame.io in a ProRes file or a DNX file or an HEVC file, and we'll play it back for you so you can watch it in lower resolution so you have access to it. So that's a pretty cool thing about 8K. and Frame.io. But let's talk a little bit about the market maturity. See, the first thing I want to talk about in a vision for 2021 is the maturity of the 8K market and what that means for what we're talking about. Now, something really great that you may have heard about that I think is really cool is a friend of mine, the renowned cinematographer Pavel Ochtel. And Pavel has basically pioneered some really incredible stuff that you've probably heard about and seen. And he's actually built a new sensor that is exceptional for the large screen and giant screen and even cinematography approaches. What he's talking about and what he's created is an 18K imager. And what's cool about this, if you look at this image that Pavel produced, maybe you've seen this online, but you grab a little box in the middle here, just take one little box and you blow that up, that resolution is actually exceptionally clear. So it's actually true resolution. In fact, Pavel actually, to prove this out, pointed out and he sort of published his own MTF chart. And so when you're looking at this MTF chart and you're seeing the resolution adoption here, essentially with the chart you're seeing here, it's derived from a 2K center crop. So you have an 18K image, which is about 260 megapixels. And you got a little HD or 2K center crop. And the measurement, what we're seeing here is 1/100th of the area of the actual frame. So what's at work is resolving the smallest area so that we can actually measure authentic resolution. Now, some people, you've probably heard the term, they want better pixels, not more pixels. I don't happen to agree with that phrase because I think it comes from people that say it that are using it as an excuse or justification to celebrate lower resolution cameras, probably because they own them. But anyway, what's happening with Pavel's camera here is he's got better pixels and more pixels. And that should be the pursuit that people should really take into account when they say that. Anyway, what this chart shows is that the MTF contrast measurement in this tiny HD crop on this chart is a value of greater than 0. What that means is that the smallest details from Pavel's camera can actually be resolved. But what about these guys? Here we've got Blackmagic. Blackmagic comes out with a 12K camera, right? You've heard about that. So that's a lot of market maturity. And let's not count out that Panavision, the DXL program, which is powered by the Red Monstro sensor. Red also has the Helium sensor. These are tools that are out there also already available, democratized. These are solutions for the 8K market. So essentially what we're looking here, the market is maturing. See, when Red was the only company to have high resolution, whether that was 4K or 5K or 6K or 8K, then people think it's an outlier. But here's the thing that's happening. The market's starting to respond to that, understanding that there can be better pixels and more pixels together, that there aren't tremendous sacrifices with higher resolution. In fact, there's advantages. And so the market having more of these trusted brands here, and Pavel, who's not yet a trusted brand, he's a trusted person, and his skills are exceptional in this space. This is a picture of market maturity. So the first thing that we need to do in planning for the future and looking at that vision is make sure that a lot of people are singing the same tune. That's happening. Well, number two here, why are we even doing this? Well, super sampling is the #1 reason, in my opinion, to be peddling all these super high resolution cameras. It's the same reason that the photography world uses high resolution still cameras, because they're super sampling the picture. Now, there is no one better in the cinema space of working with super samples than the director David Fincher. In fact, what David does is he has been for a long time taking images and stabilizing, reframing them and adjusting them to be better and more, succinct to the action that he's trying to create. So in this case, here we could see a reference still of the full aperture, the original super sample source from the Mindhunter show on the left, and then on the right, we can actually see the extracted results. So he will take a camera with higher resolution, frame inside of that, and then reposition, stabilize, even do visual effects, and push in, and all those things that allows you to have more creative control going forward. There's another group that's really big on that, so super sampling helps the creative side, so resolution as a tool. But then you've got something like the giant screen groups like IMAX. They need the resolution not for true extractions, but for scale and for clarity and dimension and depth, and that tremendous experience that you can get when you're seeing IMAX. And the more pixels on the screen, these are the types of things that really make a big difference in the experience for the consumers when they go and see that stuff. So this is what the super sample sort of formula comes to. If you're going to view in 4K, well then you've got to capture in something higher than 6K. Well, in order to get HD to look good, you need 4K. In order to view in 4K, you need at least 6K, which is double the resolution of 4K. Well, if you're going to have an 8K view solution, then you need to capture in something like 12 or above. So this is part of the super sample benefit that comes into play when we're talking about market maturity, and then we're talking about super sampling. Why is resolution useful as a tool? So our number 3 ingredient when we're talking about a vision for 2021 is bandwidth. Now, this is an important aspect because this sort of starts to tie our narrative together. And this is the opportunity for people that are innovators, inventors, manufacturers. This is type of stuff that I think really will play a huge role in this process going forward. So we know that 4G is essentially measured in megabits per second, but 5G is gigabits per second. Right? And so what's really exceptional about what Apple's done and what Samsung's done and Google's done is that now they have devices that is helping democratize 5G. I know it's still new, I know it's still fresh, but this is a major step forward from the philosophy of high resolution being democratized or high bandwidth being democratized and available to it now becoming real. Now, what's interesting is if we're going to really examine what our bandwidth issues or needs are, let's just back up a little bit. Let's go back to the 5 generations and just take a snapshot of the 5 generations, because I know there's always skeptics out there about bandwidth and availability and what it's going to mean, but we can learn from how we evolved with the technology and what was capable if we look at these old ones. So with 1G, the first generation of this, all we could do was voice calling. That was it. But then with 2G, we added SMS and MMS messaging so people could start to comment and communicate through text and things like that. Well, then with 3G, we had audio, podcasts, and music started to get really significant. Remember LimeWire and Napster and things like that? This is where 3G made the audio work with the phone. And then with 4G, well, now we got to video. And so now we have video streaming. Everyone's doing it. Everybody's capable of doing it. And we can even do that with AK source files in Frame.io. But what 5G is going to do, and what 5G is starting to promise us, is real-time collaboration and ultra-high bandwidth data transfers. Now, it's going to take some time for this to fully mature. Now, most of the people watching this know all this stuff, but if this video gets out to someone who doesn't understand this, let's just do a very basic thing. There's a low band, a mid band, and a high band to the spectrum. And so what you're able to do is use the low band to transmit signals a long way, but they're not very high bandwidth, but they have good coverage, sort of like AM radio, right? And so you have that solution. And then in the high band, you've got really good bandwidth, pretty impressive bandwidth, especially in the lab tests that have been published. But the distance for that is actually pretty limited. So maybe, I think the estimates are like a city block, something like that. Certainly bigger than your home Wi-Fi base station, but nothing like today's cell towers and the 4G LTE connection. So we're sort of seeing different companies gravitate towards different approaches. Some are doing mid-band and some are doing high-band, the millimeter wavelengths as their deployment. So that's pretty interesting to see who's using different strategies going forward with this. But essentially, at the end of the day, 5G is going to become like the fiber. It's going to become the new fiber. And we're seeing peak performance in the lab that's over 4 gigabits per second. So that's like half a gigabyte per second in at least download speed. Upload's going to be a little different. And this is going to take time to mature, but I really believe that the future cinematography is with raw cloud transfers. That's what people are going to want. And the future of exhibition is going to be in cloud distribution. And now we don't have to use super compressed or small files, and we certainly don't have to wait for them or worry about failed transfers or network interrupts, because if you can move data fast, even if it's big, there's less likeliness that you're not going to get the whole thing. Sometimes it's the long transitions, the long uploads and downloads that become the most cumbersome to manage. Well, that's going to change with 5G as well. All this democratization is pretty cool stuff for everyone. And Jared Land, the president of RED, said, in studios that have a robust millimeter wave infrastructure, it makes sense to go straight to cellular instead of Wi-Fi. I'm definitely excited about what the next few years will bring. And I am too, because I've been waiting for the 5G sort of to roll over for several years, because it gets me really excited about connecting cameras directly to cutting rooms, because we want sets and editors and post-production teams, labs, all of those people, broadcast centers to be working parallel at the same time with zero latency or sub 10 millisecond latency, so that we can truly have a collaborative experience in a way that we've never really had it before. So what's the opportunity? Well, in my opinion, the opportunity takes the three ingredients that we just talked about and sort of slams them all together. We work in the media and entertainment business, or at least most of us do. And so there's a huge opportunity for the 5G market and telecommunications and for everything from travel to military to education and so on and so forth. But what I'm passionate about is the movie business, is creative aspects of this and how this can help the relationship between a visionary who has a story to tell and a consumer who wants to watch that story. And I really think about the innovations that we can do in order to make that experience better for the creative people, better for the technologists, and better for the consumer. So this, I think, is really the picture of the opportunity. What we have to do is figure out how to innovate for our industry, because most people, let's face it, won't innovate for the movie industry because it's actually pretty small in context with all the industries out there. But what we have an opportunity to do is take the 5G network, connect them into cameras and get it on the camera roadmaps and make sure that the cameras and all the static devices that are on set have an opportunity to start hooking into the cellular network. And then we take that and we bring it to the consumers, whether that's at home or that's on the big screen in theaters when we're able to go back there. This is the opportunity to really connect these things together. There is so much room for innovation inside this space. And high resolution is where this is going to go. The consumers have wised up that high resolution counts, that you can see it. The early feedback from a lot of industry professionals that says you cannot see the difference between HD and 4K, it's just simply, I don't know what it is. It's certainly not fully the whole story. I don't want to say it's inaccurate because there's a context where that might be true, but it's not the whole story. And so the opportunity of the super sample, whether it's creative or it's impressive, the creative side like David Fincher uses, or the impressive side like the Giant Screen Association uses, those are the two areas in which super sampling is going to be helpful. And then we have these consumers that want to see things looking great. And we have a lot of the OTTs that have been pushing the narrative that good image fidelity counts, that it actually sells, that you don't want to watch things in a lo-fi situation. And of course, the consumer electronics industry has really caught up to incredible technologies, even down to the latest iPhone 12 screen, which the performance of that device is just exceptional on that side as well. So at the end of the day, this is what I believe, and we believe at Frame.io, is that in the future, we'll record digitally to the cloud where all our work can be accessed in near real time by any member of a team anywhere from anywhere in the world. That's our hope, that's our dream, but I don't think it's science fiction. This is just not a miracle that we're talking about doing, it's just a decision. And we make the decision to innovate in this direction and go this way. I have been an advocate and a fan of high resolution for my entire career because I've always found the creative and technical advantages to having more resolution to work with. And now I want to be very, very jealous about when that resolution is available to me. And so I want to get it faster and sooner. There's a whole generation of TikTokers and YouTubers that in the future, all creative people will have been a cinematographer and an editor and a director. Every human will have been that in some way, shape, or form because the access to that technology is completely ubiquitous. And so what that means is the speed in which creative people will want to interact with the work that they're creating is not going to be acceptable if it's a day apart or even hours apart. They want to work in parallel. They want zero latency regardless of where they are because they grew up with a technological medium that allowed them to shoot, edit, and distribute all from standing in the same place. Well, once they get into big productions, that cerebral approach will still remain. And so it's our opportunity to actually innovate ultra high resolution and get that material to be super sampled so it can be creative and technologically attractive, and then deliver that using high-speed technologies like 5G to get that to all the people really, really quickly, including other creative people as well as the end consumer. If you work in the media and arts and entertainment industry, our customer is the creative side. And I think that's something that's always driven me and made me excited to continue to push the envelope and evangelize to creative people that we have technologies that are going to make their lives better. So let's work together and do that. Thank you so much for having me.
Okay, Michael, all the speakers, that was awesome. And I'm sorry you just don't have much passion for this industry, Michael. It shows. So I'll start picking on you with Mike because you were the last speaker. First of all, I love your vision that everything is going to go to the cloud, that everyone will upload their content theoretically through 5G, and everything will be done in the cloud, the post, editing, blah, blah, blah. What's holding us up from seeing that vision enabled?
Well, actually, Katie's presentation, which we didn't conspire together. We just happened to be cut from the same cloth. So our stuff tends to overlap a bit. Katie made a good point about codecs because she said, look, this is one of the holdups is the compression and the packaging and the distribution of that codec stuff. And right now I actually did a presentation probably 5-6 months ago. And I talked about, I realized if you take a step back and you look at cameras and editing systems, there is a codec frenzy going on. There's codec wars. Everybody's got their own codec and everybody's building their own codecs. We do not want this, actually. I would posit, in my opinion, sometimes the market really benefits from having a lot of variations of things. That's true. But in the case of codecs, I think it's a problem because every codec is being optimized at a different speed. Some are not optimized at all. We talked about, I think in the very first, I think we saw the story about AP1 versus VP9 versus HEVC. And there's different people that support those different paths. We've got ProRes RAW. Apple just announced there was ProRes RAW. Now they have Apple RAW. So that's a new codec that Apple's done on themselves, plus ProRes. So we've got 3 from Apple alone. We got Blackmagic RAW. Of course, Arri RAW is not Blackmagic RAW, and it's not ProRes RAW, and it's not Canon RAW. This is not good for the transmission community. It is not good for the editing community. It's not good for the remote community. It's probably good for the cloud community because it takes up more space. And so they're a fan of anything that takes up more space, but that shouldn't be something we want. We should want better bandwidth throughput, faster rendering, cloud-to-cloud transferring, what GPUs can do. And what Unreal does is amazing, but Unreal, if you throw it, if you throw it 1 or 2 codecs to deal with, Unreal could be more efficient than having to support 20 codecs, right? So this is where it comes down to. We need to pressure the manufacturing group to settle on fewer codecs, which I think is probably impossible. But if anyone can do it, SMPTE can do it. So that's one of my asks.
That's a pretty tall ask.
Yeah.
So I also noticed Frame.io does support 8K files, as we at the 8K Association know, because we're moving those files around thanks to Frame.io. And AWS just announced that they're going to now support uncompressed TIFF and RAW files, but only at 4K resolution so far. What about Frame.io being able to support 8K uncompressed?
Well, we actually support it. You could put a 75 megapixel TIFF in Frame.io, but nobody has the bandwidth to play that, which is not Frame.io's business. Bandwidth is not our business. Display and capture and share is. And so we can support the high resolutions, but you don't have 2 gigabits per second yet to play that back. So, we want to support the high resolution codecs. And today you can put you can support 8K in the system, but playback is a different issue. So AWS is supporting playback of these codecs, which is a great start, and that will open up over time. And S3 just got a lot faster. S3, if you look at S3 over the last 8 years, it continues to improve in just overall speed. And so you used to have to need special access to Amazon buckets that had higher performance, but S3, which is the easiest to work with, is actually really high performance right now. I remember not too long ago, you couldn't play Arri RAW off S3. Now you can. Same cost to me, but the disks and the optimization has improved. So an Arri RAW file, which is pretty beefy, 25 megabytes per frame, that is now playing back in S3, no problem. So that's a really good sign.
So, Katie, can you use AWS and play those files back in your post-production, or you have to have everything on-prem?
Well, we're limited by the same sort of bandwidth limitations that Michael had mentioned. And so as we start to get into those larger and larger files, especially on the uncompressed side, it's significantly harder to be able to play that back because you need such a beefy pipe. So for the most part, we are leaning more and more into cloud-based and remote infrastructures. It's, partially just the need to be able to support the current business operations. But it's also forcing all of us to think about new ways of doing things, whether it's proxied or taking advantage of having materials in one place and being able to remote in and remotely control some of those different systems and sources. So you're really only sending, computer commands for peripherals, monitors, and mouses.
Mm-hmm. So where does the use of proxies in your workflow, where does that break down? Where do you need uncompressed?
Well, we hate using proxies, put it that way, because we're at the end of the process. And so every option that we have to work natively as much as we can is where we try to focus, because we're always trying to move the ball forward. And when you're in a proxy world, you're working with something that isn't necessarily representative of what you're going to deliver as a final. And so we will always have some degree of having to replace that at the end of the process. Where that does come into play, though, is right now in some of our artists' worlds, when we had moved some of our folks remotely to be able to work from their homes, their physical bandwidth wouldn't allow them to be able to even download some of the updated material that was coming to them. So in those cases, we do have to rely on a proxied version of the material just because of the bandwidth limitation.
Yeah. And then, but you can also, theoretically, you can have all the original assets in the cloud, work from proxies. You can even do the final conforms in the cloud.
Absolutely.
And get your deliverables and QC them, right? Theoretically?
You absolutely can, theoretically. And that's, I think, the other key point to making this a lot more manageable. It's the price point at which AWS and some of the other hosting companies are pricing that storage as it's needed for media companies. Our price per gig, when we look at it from a camera OCN model, and the fact that we're hosting the entire movie up there, perhaps in some cases, versus just the content that ends up in the final cut. Those are two very different financial models. And additionally, a lot of these large large internet providers, internet companies, they don't understand that the media business, and we're talking in terms of terabytes. Well, in comparison to government or bank models, which are dealing with petabytes of material, they don't quite understand that from scales of economy, from what we actually can budget in terms of media production, it doesn't currently make sense. So that also kind of needs a rethink and overhaul in order to really be more manageable.
Well, maybe you need a buyer's group of post-production companies that can negotiate better prices.
I think there's a couple of key groups out there already doing some of that education that's necessary.
Mm-hmm. So do you think it's just pricing that the cloud providers need to do a better job, or do they need better structure in the way they organize the memory?
I think it's up for discussion either way. Currently, right now, when we look at our business and the amount of storage that we would need to take on in order to support the content that we are surfacing, it doesn't make sense for us to move all of our content to the cloud because of the price point that we're looking at on a per gig basis. And we can achieve better scale with an on-prem model. That, however, changes when we start to talk about, well, maybe it's only a certain portion of that material, or maybe it's only the online the section that ends up in the final cut plus some handles. There's certainly different ways that we could tier that. But I do think that overall we've got to look at a couple different methodologies, whether it's pricing or how the media is accessed, and how easy it is or how often it is, in order for us to have a better scheme and a better adoption into cloud-based working.
Okay. So in your mind, what kind of a pricing change do you want to see? A half, a third? Roughly.
I have not run the numbers, but I can tell you right now where it's at. It does not make sense for us across the business.
Okay. Okay. I actually want to come up to one more thing you also said. There's a lack of a 8K professional monitor out there. That's absolutely true. Everything is 2K or 4K right now.
Well, and for what it's worth, there's a lack of a 4K professional HDR monitor that is something that can be put into even a client's hands.
Right. Exactly. So, one, what do you use to QC 8K content? And two, what would you like to see as an ideal 8K monitor?
For 8K right now, from a professional perspective, we're still scaling down 8K into that 4K world. So there are, the 8K monitors that are out there are really more of a prosumer, and so we can certainly QC on them. But from a color perspective, if I've got a colorist comparing between a professional reference monitor and a prosumer monitor, they're always going to revert back to the professional reference. So, even though we're taking a hit in terms of the resolution from a quality perspective, it's still something that we feel is necessary. But that's something that I would challenge, SMPTE and some of these other manufacturers to take a look at, because it's absolutely an area that is currently impeding adoption. I mean, not only in 8K, but also in terms of 4K HDR and some of the, that being kind of the stepping stone to getting into an HD world or an 8K world as well. So
would you like to see what, like a 48-inch, a 55-inch, because it's 8K as a monitor? I'm talking a reference monitor now, a full color grading monitor.
It's interesting that you asked that, because prior to COVID, I would have said, 55-inch would be great. But what we're finding, as we're leaning so much more into remote sessions and remote collaboration, we can even get away with a 24 or 30-inch, because in most cases it's a one-to-one, one person in front of one monitor. So in a more collaborative environment, I'd say probably a 50-inch, 40 something as a minimum, 50-inch would be better. And if we can get larger than that, great. But that bare minimum of really 30 inches is kind of setting the bar, at least for where we need to start at.
Okay. Great. All right, let me move on. Let's see. Terry, are you on board?
Yes, I am. I can
wonderful.
even show you my camera.
And there you are, flying above the bridge.
Yes.
So you gave some great stuff in the broadcast of 8K, and to date we've been talking more about obviously file-based workflows, but I want to turn to talk a little about the broadcast if we can. So what you did at Roland Garros in 2019. State of the art, absolutely state of the art. All the things that you innovated. If you had the opportunity to do it again this spring, 2 years later,
yes,
what would you change?
First of all, I didn't share with you the workflow we had, which was okay on the capture, okay on the encoding, on the decoding. If you recall, on the blog we made with France Télévisions was a PC with quad cards to generate an 8K output to a Samsung TV. So since then, we have made some progress. We have been able to install an app on the 8K Samsung TV, and we can actually stream Dash directly natively from the Samsung TV. Yep. So we think that consumer will not buy a PC with quad graphic card to play back. So we think consumer love to have a pop-up in their TV and see that 8K app is available. So we think we have nearly reached the consumer grade experience. I know you are going to ask me the codec question. Should we move to a different codec? The answer is yes, probably in 3 to 4 years from now. In the meantime, Harmonic has worked very hard to bring HEVC with cloud-based computation, of course, real-time and content-aware encoding to reach a VVC-like bitrate at a similar quality. And this is where it's starting to become disturbing, Chris, is people say, do we really need a new codec? So we say, not yet. We can still continue to live with HEVC. Of course, if and when 8K is becoming a massively popular application, then we need to switch to a different codec. Because in unicast at 40 megabits, I'm not sure we can serve, let's say, 10% of the population on the internet. So we have to be ready for the next wave of success, I would say, with, let's say, 2024 Paris Olympics as an example. And you can expect at that time to have a decent amount of 8K TV set in the market. And then if you have great content to show to people during the Olympics, I think you might want to find a better codec. But of course, we need to have this available on consumer device. Connected TV, I think, is number one. Being broadcast or broadband, I know in Japan, I'm hearing some background noise from Japan. But Japan believes in DTH transmission. I think in the Western world, we believe more in fiber OTT type of transmission. Yeah. And of course, if you get 600 megabit from your Fios connection in the US, you can stream at 40 megs. You probably don't need to go lower than this, but that's up to the encoder company to debate. And I believe this will be your next session.
So what about the idea of changing the infrastructure for example, the San Francisco 49ers just did a broadcast where they had 5 8K cameras on the football field, and they were taking a 1080p cut out from that going to their scoreboard. Yeah. But they were using a whole SDI infrastructure, and I'm wondering if we're ready to, for installs like that, if we're ready to do a full IP install that with JPEG XS compression, for example, that can use a 10 gig network now. Are we mature enough to do that and support 8K now?
Well, I'm going to switch my hat. I'm going to take my president of Ultra HD Forum, and I'm going to share with you some of the results we have done on interop of ST2110 at the 4K resolution. And I would say we are nearly there in terms of interoperating different types of equipment for live production. Now, 8K ST2110, I don't think this is reality yet. And I don't know who has done it. So I know we have people in the audience who probably have some opinion on how this can be done. But I would say today people are focusing mostly on HD. 4K obviously is the next things in line of sight for ST2110. 8K, I think it's still premature. I don't think there is a big production plans for live 8K production. I think what you see in the 49ers is an interesting perspective where you can capture HD out of an 8K production. And the sweet spot, I would say today, is probably single cam 4K, where you can extract multiple HD windows for low cost production and of course for better accuracy. I think you will see in the sports event more and more capture in 4K, although it is distributed in 1080p.
Yeah, I think so too. Let me turn to some of the questions that are on the chat here. This is for Michael. Speaking of the cost of the cloud, isn't the cost of 5G network capacity also going to be a significant barrier?
Certainly. There's a lot to figure out in the 5G space, especially with the millimeter wavelength sections of that. But I actually can tell you that I've been in conversations with a lot of the telecommunications groups that are deploying that, and they are exploring modeling for how this works for professional use. There wasn't a large division at a lot of these groups designed for high bandwidth transmissions. There were some divisions in the LTE space, but in 5G, there's now like a media services department in every single one of these groups. And so they're actually coming to groups like Frame.io and saying, you know, did you say the word petabyte? And we're like, yeah. And they're like, we like that word, you know? Yeah. And so that's the type of things they're like, how can telecommunications groups start to think about how to do that, which requires a different modeling. What I've been saying to them is that they essentially, their business model is to take this bandwidth and aggregate it across the millions, billions of users, right? But in Hollywood, in media and entertainment, we're small. And we have cash. I mean, we have cash because we've been doing satellite uplinks for 40 years, right? But it's like, how do we use this technology to, you know, not have to use satellite uplinks and use more of the 5G spectrum? And they're interested in that. And so I think some of the pressure that we can put on them is special pricing for us. Katie made a joke to me. She's like, the pricing Can we ask for 0? We can ask for 0, but we probably won't get it. But we can ask for special licensing. Another thing is throttling, right? Because there's so many people around these, towers and so on, that they throttle that. So even if you have unlimited data, you have unlimited data to a certain gigabyte count, and then they throttle you way down to like 500K. That's what happens today. So you have unlimited data at 500K, not useful. So we understand that in the consumer space, that sort of makes sense that they control that. But the professionals, we need our own pricing model and plans. And I suggested to them that the plans can be based on week-long plans, right? A consumer wants an annualized plan, but if you're shooting a commercial or just one sports event for one day, you're like, I need a 1-day plan. I want 1 terabyte of data for 1 day. What's that going to cost? And then I'll turn it on, and then you turn it off. That's it, right? So that's the type of modeling that we can put pressure on these groups, because they want to sell this spectrum to us, but we need to make it fit inside of budgets and workflows that work with us. And no production is going to sign for an annual cell phone plan to use a hotspot of their phone to shoot a movie or a TV show or a sports event. That doesn't make any sense. So this is some of the stuff that we have to work out as we keep the convo going.
Well, you may also have to have the realization that you'll have to set up your own base stations to create a millimeter wave transmission point and reception point, because those are going to be few and far between.
Yeah, and if you think about like a company like Teradek, if you look at their Bolt 5000 or Bolt 10,000, they have a 10,000 foot receiver, which is like a big plate, right? It's a big plate for transmission and receiving. People buy that stuff. Like, we're used to that we're not afraid of hardware. In fact, we're all nerds. We kind of like buying it. Let's be honest. So, this is an opportunity for us to work with these millimeter solutions that are field deployable, right? We just need a field deployable kit. Like, the American entertainment industry isn't afraid of expensive gear. I mean, a techno crane's several $1 million, and we rent them. We like them. They're great. They make great shots. How do we get this? We just want a solid connection that's reliable at a price that we can control, secure, high speed, and no more disk drives, no more shipping. And that's sort of where the 5G world will, I think we're going to, the question is, are there going to be, the question exactly is the 5G network costs, are they going to be a significant barrier? I think if we work this out, the maturity of 5G and the appetite for shooting to the cloud is going to converge at the right time. And that's what we need to try to engineer together, that there's an appetite for this, and there's a bucket, so that we can do a fetch and a push and a fetch, actually. And we do those two things at the same time. And we might get peanut butter and jelly. It might happen.
Okay, we're getting short on time, so I'm going to move on. Actually, this is a question for Andy. We learned about high density encoding for the ARRI raw earlier today. Has that been included in the equation with the universal engine? You mean the Unreal Engine?
Yeah, the Unreal Engine. Yeah, sorry about that.
I'm assuming, do you mean playing back ARRI raw as far as the codec goes?
Yeah, earlier today we were in one of the 8K paths, and they talked about high density encoding for the ARRI raw files, which basically knocks it down to a ProRes.
Sure.
Yeah, and that engine you showed, I've been using gaming computers close to 10 years now, as opposed to regular computers. I started out with an Alienware, which played significantly better. And now I have an MSI, which plays a lot of raw files, 4K files, without any problem. So I was just wondering, with that high density encoding coupled with your engine, that seems, that we could get past a lot of bandwidth issues and those kind of things.
Yeah, sure thing. So we definitely, we see users, like the use case you saw for what I presented was more of these large screens, kind of IMAX style, if you will, being able to put content. Sometimes, filmmakers want to put video content on that. Currently, our best path forward is we play back EXR sequences in real time. So we've invested heavily on some of the EXR playback in engine, because we're a fully linear engine under the hood. So you can do kind of high-end film VFX like work with high dynamic range imagery. We can definitely look at the RE codecs as well as many of the filmmakers. Some of it comes down to we definitely prefer GPU and decode codecs so that we can play those back as efficiently as possible. And when you're trying to play back, I said on these 16K screen or cluster type method, then you need as much possible bandwidth as you can. So yeah.
So the Unreal Engine's it's not optimized necessarily for the Sony PlayStation 5. It can run. Yeah,
for sure. It's you can run it on any super high end PC. So obviously when we're doing the kind of I gave the use case of the Mandalorian, those are high end PCs with even now like multiple graphics cards in them, and so it scales way beyond kind of like the gaming console in terms of its capabilities.
Yeah. Right. Yeah, no, for sure. But yeah, I was just wondering, kind of thinking ahead with, right. If you could, run it on a PC and, the workflow would be spend money on the computing up front to save money in the post on the back end, with the oversampling that Michael talked about. A lot of us independent editors and stuff have been doing that for years. It's just you need to deliver 2K. You shoot it 4K and just leave it wide, and then you're moving around the camera. I mean, I did that for my presentation for SMPTE. I shot it wide, and you see camera moves and everything in there, but the camera never actually moves.
Right.
It's all oversampling done in post.
Yeah.
So,
pan and scan.
Mm-hmm. Yep. Yeah, it comes down to us just supporting the specific codecs really in the decode process. So it's kind of a matter of time, if you will. So we support ProRes and Avid DNX HRs and EXR sequences, for example. So some of those play back kind of better than others in terms of their GPU usage. And if you're just simply playing it back, then and there's not a lot of 3D content, then you can definitely play back multiple streams all at once.
So certainly virtual production right now is a topic du jour. Do you really think this kind of capability will be the future of filmmaking? It's certainly, maybe not for small independent guys, but for bigger budget.
Yeah, I mean, I think it's kind of, the Mandalorian's a good example. In some ways it was started as a proof of concept, but some of my background, I come from the broadcasting world like everybody else here, and kind of bringing the tools and technology that we had everybody's using studio LED walls and that kind of stuff, was to be able to take that technology and clustering the Unreal Engine and all the PCs together, you can build a giant canvas. And so being able to light the actors interactively with that kind of stuff, we definitely see that as the future of these smart stages and the ability to kind of bring the set and the location to your cast, if you will. So you could, show up on site. I think there'll be a number of these smart stages. I think we know of over close to 160 smart stages now being built all across the world.
Wow.
Yeah. And so, I think you're going to see more and more of that becoming the norm, that the film side is going to start to move more towards the television side. Because as soon as you see, the stage and the requirements, it starts to look a lot like a TV studio. You have a brain bar, you have whole SDI infrastructure, you have, sometimes media servers, lighting consoles. Like it, really does become kind of a TV studio like setup.
Yes. Well, unfortunately, we need to end this session right now. I could go on, but we do have another one that has to start in a few minutes. So thank you very much, panelists, attendees, for your participation and questions. And I bid you a good night. Thank you.
Thank you.